All right, so this is Chapter 4, Section 5, Isosceles and Equilateral Triangles. This is the notes. Please include your learning objective, which is to use and apply properties of isosceles and equilateral triangles. This may be a product of my profession, but I love it when triangles are isosceles or equilateral. I love it. What is an isosceles triangle? Two sides congruent, and equilateral is when you have three sides congruent. So we are going to just take a peek real quick here. This is an isosceles triangle. It's got two of the legs are congruent. The vertex angle is the angle that is in between the two legs. The base angles are on the right and the left of that, unless it's upside down, and then they're the left and the right. Unless it's rotated 180 degrees, and then it's left and right. Unless it's rotated 90 degrees, and then it's top and bottom. But the base angles are the ones, not the vertex. All right. Theorem 4.3 says, if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So this is why I love isosceles triangles. We know we have two sides. The angles opposite those two sides are also congruent, so we can automatically call those two angles congruent. The converse of an isosceles triangle theorem says the reverse of that. If two angles are congruent, then the sides are also congruent. So it goes either way. Theorem 4-5 says, if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. This one is not as self-evident, so let's highlight it to make sure it doesn't get mixed in. It's got a different flavor than isosceles triangle theorem and the converse of the isosceles triangle theorem. So let's break that down a little bit. If PQ is congruent to RQ in the triangle PQR, how about we draw that? Because I don't like to talk about triangles. We'll put Q at the top, R on the right-hand side, P on the left. Triangle PQR. So we got PQ is congruent to RQ. Then angles which two angles will be congruent? Which two, y'all? P and R. X to the yes. P and R. And then take a look at this little diagram here. If I have triangle CAB and I got this D, he cuts angle C in half because I got two congruent angles. Then illustrated below is which theorem? 4-5. Theorem 4-5, because it's the perpendicular bisector guy. Because it's not isosceles. It's an isosceles triangle, but there's so much more information. Okay, let's look at our little picture here. Is W, oh man. So I like to mark up my figures. So angle WVS, congruent to angle S. Angle S is right there. And is TR congruent to TS? And spline. All right. So we got a whole lot of craziness going on here, so let's back it off a little bit. Let's look at just this triangle, VWS. We know that these are isosceles. So what does the isosceles triangle theorem say? That the two angles are also going to be congruent. So WBS is congruent to, so we say yes, because triangle WBS is isosceles. So angle WBS is congruent to angle S. Now let's look. Is angle R congruent to angle S? What do we say, y'all? So we are going to say yes, since angle R is congruent to angle WVS, and that's given. And angle WVS is congruent to angle S. Then by the transitive property, angle R is congruent to angle S. So we're going to put a congruent mark right here. Right on S, because he's congruent to V, and then he's also congruent to R. So now, is TR congruent to TS? And if yay or nay, explain. So TS, so the answer to this is yes. By the converse of the isosceles triangle theorem, since angle R is congruent to angle S, then TR is congruent to TS. All right, so let's see if, given an isosceles triangle, we can noodle out values of x. So we're going to suppose that angle A is 27 degrees, so I'm going to go ahead and write 27 in that corner. What is the value of x? X is this tiny angle here. He's the angle you get when you bisect B. All right, so since CB is congruent to which other side? AB, thank you much. We have an isosceles triangle. And if we have an isosceles triangle, we know that angle A is equal to what other angle in our triangle here? C. Hex to the yes. So we can say that C is 27 degrees. Yay, we're getting somewhere. And since BD bisects the vertex of isosceles triangle, BD is congruent to AC. And so the measure of BDC is going to be 90 degrees. All right, so now we're just going to isolate triangle BDC. We're going to say this is 90, this is 27, this is X. Can we solve these guys? Easy peasy lemon squeezy. All we have to do is go 90 plus 27 plus X is equal to 180. $117 plus X is equal to 180. Subtract 117. We'll go old school on this. X is equal to 63 degrees. And then we double check, because sometimes they ask us for weird things. We solve for X and then the answer is not X, but it's like a different side length or an angle measure or whatever. But in this case, we are solving for X. So X is equal to 63 degrees. All right, so a corollary is not what you have when your heart starts beating really fast. A corollary is a theorem that can be proved easily using another theorem. And since a corollary is a theorem, you can use it as a reason in a proof. So we'll start seeing them in our little proofs. So the corollary to 4.3 and 4.4 is if a triangle is equilateral, then the triangle is equiangular. So you identify one or the other. You can automatically say if all sides are equal, congruent, then all the angles are also congruent. And then if a triangle is equiangular, so the converse is true, then the triangle is equilateral. All right, the corollary used to illustrate below is if I have all sides congruent, then I have all angles congruent, is theorem 4-3. Corollary to theorem 4-3. Almost done. So take a look at this little diagram here. We're going to suppose the triangles at the right are isosceles triangles, and they've been marked as such, where angle ADE and DEC and ECB are vertex angles. If the vertex angles have measure 58, what are angle A and angle BCD? Which is this big one here. Awesome. Bless you. All right, so let's find the measure of angle A first. So if we take just the triangle, this is ADE. We know we have angle X there, and we know it's isosceles because it's got two congruent marks. Boop, boop. So I know that my base angles are congruent. So I'm going to say that 58 plus X is equal to 180. I'm going to simplify this a little bit. 58 plus 2x is equal to 180. Subtract 58 from both sides. And I get 2x equals not 130, because it's 58, so it's 122. Divided by 2. And x is equal to 61. So the measure of angle A is 61 degrees. So let's take that information and we're going to apply it. So if angle A is 61, this is B, C, This is 58. This is 61. This is also 61. Does everybody understand how I got the 61 right here? That's EDB, and because the way this rolls out, since I have congruent angles, this is the base of triangle DEC. So the base angle measures for all of these triangles is 61. So the measure of angle BCD is 61 plus 58. Or 119.